I sat right next to you during the
Alright,
I heard it was like really hard.
so once again, we're going to be talking about particle motion. And remember that in calculus, the particle motion that is usually described or talked about is rectilinear motion. So the particle moves in the left or right direction only, okay? So that's kind of what we're going to be talking about for right now. Later on when we get into other sections, we'll talk about the other motion. So left or right. Pretty good? Alright, so in this lesson we developed the ideas of velocity and acceleration in terms of position. Okay, we will speak of two types of velocity and acceleration. We'll talk about average and instantaneous velocity, and we'll also talk about average and instantaneous what? Acceleration, right? And we'll talk about how they're related to the position function, and hopefully in the end put them all together and see how they tie to each other and see how they relate to a function and its first derivative and its second derivative, okay? Alright, so for reference purposes, when we start talking about average and instantaneous velocity, we're going to have to know something or relate to something as the position function. So we're going to use P of t to represent the position function. Good? Sometimes they denote it using other variables, okay, or other names. So I'm just going to throw them out there. So sometimes they use S of t or x of t. How do you think they would use x of t? Right, because it's a movement on the x-axis, right? Movement along the x-axis, left or right. So for our purposes, we'll use p because I think it relates to position, but I mean, I don't know. Sounds good? Yes? All right. What do you think of when I say the word velocity? Displacement over time? Oh my god, so you guys are taking physics stuff. Okay? More simple than that. Change?
Change in position.
Change in distance? Over time? Oh, so is that kind of like y2 minus y1 over x2 minus x1?
Whoa.
Oh, wait a minute. What would that be? Slope? And what's another word that we use for slope? Rate of change, right? So velocity is actually a rate of change, right? And we know that whenever we find a rate of change or when we find a slope, we're finding a derivative, right? Yes? So velocity is actually the rate of change of what? Of the position. So this will be the rate of change of position. So it's telling you the rate at which the position is changing. Yes? That's what velocity describes. Remember, velocity has magnitude and direction, kind of like a what? A vector?
Yeah.
So like if velocity were negative, what do you think that would mean?
Going in the other direction.
Moving in the opposite direction? If we're talking about left and right motion, what do you think it would be moving? To the left, right? If velocity were positive, then you could say the particle's position was moving to the
Right.
right. Very good. At a particular rate, right? If I say I'm going 75 miles per hour, and we're talking about rectilinear motion, that means I would be moving to the right at what rate?
75 miles.
75 miles per hour, right? If I say I'm going negative 75 miles per hour,
Going to the left.
I'm moving to the left at the rate of at the rate of 75 miles per hour. Got it? Yes? How long does it take you to go 80 miles if you're going 80 miles an hour?
How what? What did you say? How what? Okay, what did you say? What did you say?
How long does it take you to go 80 miles if you're going 80 miles an hour? 1 hour? Sure? Yeah?
It takes time to accelerate.
Yes.
It takes time to
You have to figure out
accelerate.
the tires. Like, how fast are the tires spin? You think that makes a difference?
It takes it depends what car you have.
Oh, it depends what car you
Because
have.
like you can only go like 16 miles per hour like in 2 seconds, and like that's like adds more time. And,
16
Remember that video? Yeah?
oh, the girl,
The
right?
girl, yeah.
Oh, that's pretty cool.
Okay, anyways, I just thought I'd throw that in.
Like if I can go 60 miles per hour in 1 hour, how long does it take me to go?
Alright,
2
so anyways,
hours?
so
Divided in 2, like.
what do you think the formula would be to find average velocity on the interval A to B? We said velocity was a rate of change, right? So if I say average velocity, it's like asking for average rate of change of position. So is that kind of like A-rock? I hear some people saying that. Bless you. Wow. So that's the A-rock of the position. So what would the formula be to figure this out? P of B minus P of A over B minus A. So the basic slope formula, right? We're finding the average velocity from point A to point B. On average, you traveled at this velocity. Does that mean that you traveled that velocity at every moment in time? No, it just means on average, right? Does that mean that you were always going to the right?
It should be.
No, it doesn't mean that you weren't going to the right all the time, right? If your answer was positive. It could mean that on average,
Oh, you're going there.
you were going to the right. You understand? Cool? Alright, anyways. The other velocity is instantaneous. Instantaneous velocity. How would we find that? How would we find instantaneous rate of change? And let's be more specific. At t equals c. So we need a specific moment in time, right? If we want instantaneous velocity.
Yeah.
So that would be like saying p prime of c. So when we want IROC, we're looking for the derivative of the original function which we're relating to the position, right? What would be another notation do you think they would use for instantaneous velocity? What letter would be wise to use for velocity? V? Okay, so when they denote something as V of t, right, from here on forward, it's understood to be instantaneous velocity. Okay, there's no notation that is used for average velocity. You just have to write average velocity. Okay? Good? If we write V of t, it's understood to be the instantaneous velocity. It's the derivative of the position function. The first derivative. Good? Alright. So let's do an example here. A particle's position is given by the function p of t equals e to t sine of t. So that's the function of what? Is that velocity, position, or acceleration? Position. How do I know? Is it p of t? No. Because it says the particle's position is given by. Okay. Where p of t is measured in centimeters and t is measured in seconds, answer the following questions. What is the average velocity on the interval? From 1 to 3 seconds, indicate the appropriate units of measure. So what would I have to do in order to find that?
P of 3.
A-rock? Alright.
P of 3 minus P of 1.
So the average velocity
Over 3
is going to be p of what? 3 minus p of 1 over
3 minus 1.
3 minus 1. Alright, so let's do that on our calculators. Do you guys remember how to do both of them at the same time?
Yeah.
So control N so I can start from scratch. How do I do 3 and 1 together in the same function? Now braces,
Braces, 3, 1,
3 comma 1,
and then control bar,
control bars,
X.
I'm gonna put T just to be fun. Okay, so I'm storing them for the letter T since that's the one that you're using. So e to the T times sine of T, enter, and do we get the values?
Hold on, I don't have my computer.
Bam, I get both of them real quick, I don't have to sit there and type each one in there, right? So let's subtract them. So 2.834 minus 2.287 divided by 2. What do we end up with?
So you just store them and then you put the formula?
Yeah. Positive point?
0.274.
274? Okay, and what would be the units? What were the units of the numbers on the top?
Centimeters per second.
These were centimeters and the numbers on the bottom were seconds, so this would be centimeters per second, right? Okay. So what does that describe in terms of the problem? What could we say? On average, okay, so on average, from t equals 1 to t equals 3, what could we say? Particles position is
Is increasing.
increasing? Okay, we could write that. We can write that for now, if that's all you can think of. Is increasing
Is it going to the right?
at a rate
Guys,
Up?
increasing to the right.
0.274 centimeters per second?
Yeah, wouldn't it be
Going to the right?
So is it kind of weird to say that its position is increasing?
yeah, wouldn't it be
So, what could we say instead of its position is increasing? So the particle is moving to the right? Why can we say to the right? Because the velocity is positive, right? Okay, so it's the position or the particle's position, the particle is moving to the right at a rate of 0.27. Okay, we're gonna get to that in a little bit. Right now, this would be okay. Would this still be correct? Technically? Yeah? Kinda doesn't make sense though, right? How can position increase? Right? You put moving to the right? Okay, that's cool. Alright, how about instantaneous velocity? What do I need for that?
The derivative.
I need P prime, right? Let's do it. P prime of T. Can we get the derivative of this guy? What do I need to do, Robert? Product rule, okay, good. It's like the one on the test, right, with the K? Okay, so derivative of e to the t, e to the t times the second sine of t, plus the first, e to the t times the derivative of the second, cosine of t. Right? What's the derivative of Mr. Science? Yeah? Good? Alright. So now we need to evaluate this derivative at what? 1.5. So go ahead and use your calculator to do that. Plug in 1.5 there and tell me what you end up with. E to the 1.5 times sine of 1.5
Nothing.
plus e to the 1.5 times times cosine of 1.2.
You do UH is UE. UE to UH. And there's nothing, there's a 1 in front of it. The 1 moves down. There's nothing there.
Uh-huh.
When you have
Yeah?
you did the derivative of the second times the first.
No, I did the derivative of the first times the second.
Oh, okay.
So the derivative of e to the t is e to the t times 1. You guys did it a little bit different.
Yeah.
I do it like this so that way there's no confusion as to where to put one, like it just goes in order. But you could do it the other way.
I got
The first times the derivative of the second plus the second times the derivative of the first, but then you're switching stuff around. Sometimes kids get confused.
I'm wiping my nose.
Good, what do we get, Pablo?
4.787.
4.787? And what would be the units?
Centimeters per second squared.
Centimeters per second squared? Or just centimeters per second? Is it just centimeters per second?
Yeah.
Yeah? Because it's a rate of change of the
Oh,
position, right? Okay? Distance over
You're just not, no, it's not.
time? Yeah? Okay, anyway.
Is that all this thing
So-
about-
What would this describe? How could I use it? What could I say?
Not blocked though. Different.